let's talk about how to use R specifically for categorical variables. So here we've got a question that's talking about somebody who was scanning through some of the news items, and every time they found some topic about either federal government, foreign policy, local community, provincial, or sports, they tried to indicate whether they felt like there was negative news, positive news, just news without any bias, or if there was some conflicting news, at times positive, at times negative. So they went through and they recorded how many times the topic got brought up, as well as how they felt it was being portrayed. So these are not numeric qualities, but falling into categories. So here, I think the idea that they want to find out about is if there's a relationship between what type of news and if it's reported negatively, positively, or you know how it's reported. So this is a test of independence. So the null hypothesis should be that um, the two categories, which is like how the news is reported and what kind of news it is, the null hypothesis is that they have nothing to do with each other. They are independent features, and the alternative hypothesis is that they are dependent on each other. There is some sort of relationship between the two. So, when it comes to handling the data, that's a big part of how to get R to help you run this test. Um, there are a number of ways to input this data into R. So there was a data file associated with which I downloaded, and then let me just have a look at what it looks like. So I downloaded it and then imported it into R. And here there are three columns. One that just says 1, 2, 3, 4, and so on. One column that says if the news was positive, negative, no news, or both. And then one column that also says what the type of government or what kind of news it was. So that's the kind of data, which is kind of hard to absorb in this manner. I think the idea that would be nice is to actually get this information into sort of a summarized table. So this isn't going to work too well. If I just try to put a table of the file, the reason that it's not going to work is because I actually have three columns here, 1, 2, and 3. If I only had two columns, actually just saying table of the data would work probably pretty nice. So instead of just doing table of the whole file, I'm going to use table of here columns 2 and columns 3. So column 2 is this one here, which is called column, and then here column 3 is this one that's called row, and I'm not really caring about this value, this column of numbers there. So if I use that, then here I can get conflicting news, negative news, no news, positive news, and the various types, which is fine. That's a great way to have the data. However, like the question has here the columns being the news positive quality or negative quality, and then the rows being the type. And that's sort of the opposite. I've got the rows and the columns mixed up here. So I just did the same command as before. Instead of doing column 2 through column 3, I did column 3 through column 2. I just switched the order here, and I think it was nice then to get basically the same table that is being presented to me here in the question. The other way to do this is if you don't have the data given to you in a file to download, I can actually just create the table quite quickly. So what I did here was I read in the numbers 6644 and then 6464, and I just kept on going like that. So here I put in the number 6644, 6464, and I kept on going. And then I said the number of columns, here I counted columns as 1, 2, 3, 4. And then I am doing it horizontally. So it says by row is true. So that means I am giving it the numbers horizontally, 6, then 4, then 4, then 6, then 4, then 6, then 4, then 5, then 4, and so on. I am not giving the numbers vertically, which would be 6, 6, 5, 4, 4. Okay, so if you wanted to give the numbers vertically instead of horizontally, you could set the by row to false. In this case, I have done it horizontally. So here, I can make a matrix or a table where here I made it and then I showed what it looked like. I haven't currently got any names attached to the table, so I can put in column names and row names using these commands that you can have a look at here. So here, if I put in the column names as uh, convoluted or conflicting, negative, none, and positive, and then I can put the row names in as federal, foreign policy, local, provincial, and sports. Then if I have a look at what that looks like again, I have a table here with the corresponding names that I chose. So you can either choose to download the data like I did here and then just indicate which part of the data that I am really interested in, which looks like this. And then I can do the chi-square test of independence by saying chi-square dot test, and then I can indicate the part of the table that I'm interested in. And then here I need to set the correction factor to false. And that gives me the chi-squared test of independence. The other thing that I can do, like if I didn't do the downloaded from the CSV file, is if I did just create a table from a matrix and I called that D2, then here I can also just say, do the chi-square test on not this table that I downloaded, but just this table that I created called D2. And again, of course, remember to set the correction to false. The other thing that you can do, instead of just running the test and getting the results, you can run the test, but save all that information in some vector that you call whatever it is you want to call it. I've called my test. And then if I call the test, then of course I get the same information as if I just had typed chi-square.test. But one of the nice things about putting this test into a name like test is that when I use test and the $sign, then I can particularly look at the individual expected values. I can look at the observed values. So sorry, that's here. I can look at the observed values and I can find all the individual contributions to the chi-squared test statistic by saying, find the observed scores minus the expected scores squared divided by the expected scores. And then here, these are all of the contribution to chi-squared test statistics. So this question isn't asking for much of that. It just asked for the test statistic of my chi-square test. I do know that on your assignment that you will have to find some of the observed values and some of the contribution to chi-square. So I think that you'll be able to manipulate this kind of code to make that very useful. The other thing that does show up on assignments is when the question will ask about a critical value. So I guess let me just make sure that the package Mosaic is installed and loaded. And then here I'm going to use this command from Mosaic simply so that I can get a picture to share with you. Here, this is the chi-square distribution. I've used 12 degrees of freedom simply because the test statistic here has 12 degrees of freedom for this test of independence. And so this is what it looks like. And then if I'm not interested in the p-value, the p-value, of course, is associated with the test statistic. But if instead I'm looking for the critical value, then here, if alpha is on the upper tail, then the value that corresponds with this 5% alpha, so here the purple is 95% and the yellow is 5%, then this value here, where purple meets yellow, is the critical value. Okay, so if you don't want to use Mosaic, which you don't need to, the only reason I use Mosaic was just to get that nice picture. You can just say this is Q of chi-square, so where the cumulative area is 95% and the degree of freedom is 12. And you can find then, let me just highlight this and run the code. You can find then that the critical value, that is the point where 95% is on the left and 5% is on the right, the value will be 21. And then you can, if you like, you can use critical value approach and you can compare your test statistic to critical value. In this case, you can see that the test statistic is definitely on the left side of the critical value, which would be a fail to reject situation. Alternatively, it might be just as easy or maybe even easier to have a look at what the p-value uh, is. Here I've got an extremely high p-value, which of course also indicates that I need to fail to reject the null hypothesis. So here I just quickly going back to what my hypotheses were. The null was that there is no relationship, and the alternative is that there is a relationship. And what I've done here is I've got a big p-value, so I'm going to fail to reject the null hypothesis, which means based on this data, it doesn't look like there's a relationship between what kind of news and how it is reported. So it does appear, because the p-value is so high in this particular example, that these two factors are independent of each other.